C6.3 extraction of aluminium. Answers to the questions for this section, starting from question 7. Write half equations for the reaction that takes place. 2 moles of oxygen 2- ions produce 1 mole of oxygen and 4 moles of electrons. Because oxygen loses electrons, it's been oxidized. Remember, oil rig. Aluminium, 3+ ions, gain 3 electrons and they produce aluminium. And that's been reduced because aluminium has gained. So reduction is gain of electrons. Give 2 reasons why the extraction of aluminium is expensive. It's expensive to melt it. Even with cryolite, it's still a high temperature, and because of the large volumes, it's a huge amount of energy that's needed to melt it, so expensive. And also the electricity used for electrolysis process, because of the quantity of electricity needed, it is expensive as well. Number 9, give 3 uses of aluminium and explain why it is used for each particular purpose. So car bodies, because it is lightweight, so therefore you'll get much better fuel economy from a car that has aluminium body. Components and wheels, alloys, particularly with the alloy wheels, because they can look different colours mixed with different metals. Aluminium makes them light, it's strong, and also it will prevent it from corroding. Aircraft bodies, because it has low density, so it's lightweight material. Kitchen foil, because thin aluminium is quite malleable, so you can use that to wrap food items. High voltage power lines, because it's a good conductor of electricity, and also low density. Grade 8 questions. So we're starting with 7, bizarrely. A. Talking about an experiment that Sir Humphrey Davy did back in 1807. He electrolyzed potassium, and you're asked to explain why this electrolysis did not work when it was solid. And that's because the ions in the potassium compound were not free to move and carry a charge. And you'll know that you have to either dissolve this or melt it for those ions to be able to move and conduct a charge, and then you can electrolyze it. B. He then electrolyzed molten potash, or potassium hydroxide, and discovered that potassium collected at the cathode. Describe how potassium atoms are formed. Well, we're describing here, so potassium ions, K+, are attracted to the cathode where they will gain an electron. And that will form potassium metal. Write a half equation. K plus the electron gives potassium. It's reduction because it's gained electrons. Part C. Clue here is that the potassium chloride has been dissolved, so it's in water. Okay, so underline your key information there, it's important. Name the gas that's produced at the negative electrode. Well, it will be hydrogen. And explaining why, it's because hydrogen is less reactive than potassium. The least reactive positive ion is always given off first. So hydrogen will be given off first. And then we're going back to C4 here with some calculation questions. Calculate the percentage by mass of aluminium. So the first thing we do is work out the formula mass, Mr, of aluminium oxide. So we add the masses of each component. So 2 aluminium, 3 oxygen gives us 102 grams. The mass of aluminium in this compound is 27 plus 27, which is 54 because there are 2 of them. And then the percentage of aluminium will be the 54 from the total amount of aluminium divided by 102, which is the total mass of aluminium oxide, multiplied by 100 gives us 52.9%. And I've put that in as 3 significant figures, which is a good place to go with these calculations, unless they tell you otherwise. B. Chromium can be extracted from chromium oxide by displacement with aluminium. Write an equation to show this reaction. Chromium oxide plus 2 moles of aluminium give us aluminium oxide and 2 moles of chromium. What does this tell you about the reactivity of chromium compared to aluminium? Well, chromium must be less reactive than aluminium because aluminium is displacing it. Part 3, some of your favourite calculation questions here. So calculate how many moles of aluminium is needed to make 208 tonnes of chromium. So in this instance, I'm going to ignore the tonnes part and just use the number 208 to start with, okay? We'll come back to the tonnes at the end. So 208 tonnes, I'm going back to our equation up here. Remember, in these structured layered questions, you go back to original work here. We've balanced this correctly. So 208 tonnes of chromium, how much aluminium will this make? First thing we do is convert the mass of chromium into moles. And we do that by dividing it by the formula mass. Or the atomic mass, actually. That's a mistake. It's the AR here because we're talking about the element, not a compound. So 208, which is the number of tonnes, divided by 52, which is going to be the mass of chromium, gives us 4 moles. Part 2, reaction ratio of aluminium to chromium is 1:1, and I know this because if we look at the equation, 2 moles of aluminium will make 2 moles of chromium. So reaction ratio here is 2:2, which is the same as 1:1. So if we have 4 moles of chromium, it will make 4 moles of aluminium. Part 3, convert moles of aluminium into a mass. So 4 moles of aluminium with a mass of 27 is 108 tonnes. Now, I've put the tonnes back in at the end. Okay, so we've worked through the numbers, ignored the tonnes, and then put it in at the end. Okay. Lastly, 2 important uses of chromium. There are quite a few. It's used in stainless steel to give us a tough, corrosion-resistant material used in kitchen sinks, most commonly. Catalysts. These are substances that speed up chemical reactions. So for certain chemical reactions, this will speed them up. Pigments, paints and dyes, inks, they give bright greens, yellows, reds and oranges. So there's a whole range there depending on the chromium compound. And rubies get their red colour from chromium. Not really a use, but it's quite an interesting fact to note.